Hello students, welcome to the channel Chemistry is Fun. In this video, let us learn about how to calculate the hybridization of neutral molecules, cations, anions in a simple method. Okay, so there are already formulas given on the screen where n is equal to half into G plus M. So that means n is a neutral molecule. Okay, neutral molecules are those which do not have any charge on them. C is a cation. Cations are usually positively charged particles. A stands for anion. Anion is a negatively charged particle. And G indicates the group number of central atom. Group number of the central atom. And M indicates monovalent atoms. Monovalent atoms are those which bond only by a single bond to the other atoms. So let us use these formulas and calculate for different examples. So let us look at the first example of a neutral molecule. So let's take one simple example like BF3. Okay, the first simple thing that you need to know here is find out the central atom. So among boron and fluorine, the central atom is boron. How can you identify a central atom? The central atom is usually an element that has greater valency compared to the other. So boron can bond with 3 atoms at a time, but fluorine can bond only with one atom at a time. So our central atom is boron instead of fluorine. So apply this first formula, n is equal to half into G plus M. N is equal to half is a constant into boron belongs to third A group, which means its group number is 3. So put 3 in place of G plus how many monovalent atoms we have? This is 1, this is 2, and this is 3. So there are 3 monovalent atoms. So put 3 over here. So you get 3 plus 3 is 6 by 2, which is equal to 3. So hybridization number, if it is equal to 2, then it is sp hybridization. If the number is equal to 3, then it is sp2. If the number is equal to 4, then it is sp3. If the number is equal to 5, then it is sp3d. Why are we starting with number 2? Because hybridization is a concept which is formed by intermixing of atomic orbitals. You cannot mix only one type of orbital. There has to be minimum of 2 types of orbitals. So we start with the number 2. Okay, so this is the hybridization now for BF3 molecule, that is sp2 hybridization. Now you can get a question, if there are no monovalent atoms in a molecule, then how should we do it? Let us look at such example also. The example could be SO2 molecule, sulfur dioxide. So here in this the central atom is sulfur again. So sulfur bonds with oxygen by a double bond and bonds with another oxygen by a double bond. So here oxygen is a divalent atom, sulfur is also a divalent atom. Though our central atom is sulfur, what is the group number of sulfur? Sulfur and oxygen both belong to 6th A group or chalcogen family. So its group number is 6, plus there are no monovalent atoms. Both the oxygens are divalent. So the number of monovalent atoms in this molecule is equal to 0. Okay, then the remaining part is 6 by 2 is equal to 3. So when the number is equal to 3, the hybridization, you know it as sp2 hybridization. This way we need to calculate the hybridization for simple neutral molecules by applying the above formula. Now let us look at the calculation of hybridization for cations. So cations, what formula we have? Half into G plus M minus C. So what is the extra thing that we need to do here? We need to remove the charge present on the cation. What is a cation usually? A positively charged molecule or a particle. So if I'll take here NH4 plus ion, which is ammonium ion. NH4 plus ion is called ammonium ion. Now the overall charge on this ion is 1 positive charge. Usually whenever you write positive charge in chemistry, that means there is no electron in it. Okay, that charge you need to remove, or that many electrons are less in the molecule. So calculate the hybridization here. Half into, again the central atom is nitrogen, because nitrogen valency is, maximum valency is 4, minimum is 3 compared to hydrogen. Hydrogen valency is only 1. So the group number of nitrogen, nitrogen belongs to fifth group or Nicogen family, plus number of monovalent atoms are 4 around nitrogen, minus the total charge present, positive charge present on the ammonium ion is plus 1. So you need to remove that particular charge from the overall value. So it is 5 plus 4 9, minus 1 is 8 by 2, which is equal to 4. So as we have calculated above, if the value of hybridization is equal to 4, then the hybridization is sp3. So ammonium ions hybridization is what? sp3. The same way, if there are no monovalent atoms in the molecule, then what we need to do? How can we calculate? Let us take one such example like NO2 plus. What is NO2 plus called? Nitronium ion. NO2 can exist as neutral molecule or as a dimer or as an anion or as a cation. It can exist in any way possible according to the reaction. So this is a nitronium ion. NO2 plus, again nitrogen is having more valency than oxygen. Nitrogen is the central atom. So half into, as you know already, nitrogen's group is 5, plus oxygens are again divalent. In this molecular ion, there is no monovalent atom. So put 0 over here. And what is the charge, overall charge? It is plus 1. So remove that 1 from the overall value. So 5 plus 0 is 5, minus 1 is 4 by 2, which is equal to 2. So when the overall value is equal to 2, the hybridization is sp hybridization. So this way we can calculate for cations. Now let us move on to the anion calculation of hybridization. Half into G plus M. Here we do exactly opposite, that we shall add the charge present on the anion. Okay, so let us look at one example. The example could be ICl2 minus. Okay, this is the example. Iodine chloride, iodine chloride ion. Okay, so here iodine is the central atom compared to chlorine. So the hybridization here is half into iodine and chlorine both belong to 7th A group or halogen family. So the group number of the central atom is 7, plus how many chlorine atoms are there? 2 chlorine atoms, and 2 chlorine atoms are monovalent atoms. So you write it as 7 plus 2 plus, what is the overall charge? You can say only 1 minus. That means there's only one negative charge. You need to add that charge. So which is equal to 7 plus 2, 9 plus 1, 10 by 2, which is equal to 5. When the overall value is equal to 5, then the hybridization is said to be sp3 dehybridization. Similarly, let us look at one example which contains divalent atoms. That is, you can take SO4 2 minus. What is SO4 2 minus? It is called sulfate ion, or you can write it as sulfate anion. Okay, negatively charged ions are usually end with 8 or ide term. Okay, so here also the central atom is sulfur. Sulfur and oxygen belong to group 6, plus there are 4 oxygens, all the 4 are divalent, so there is no monovalent atom in the molecule. So put 0. And now here the charge present in the molecule is minus 2. So in the calculation you need to add that 2. So here 6 plus 2 we get 8 by 2, which is equal to 4. So the overall hybridization of the value is 4 and the hybridization of central atom is sp3. The most important point that we need to put in mind is hybridization we calculate only for the central atom. Hybridization is calculated only for the central atom. Central atom identification is very important. Central atom is that atom in the molecule which has got higher valency compared to the rest of the bonded atoms. So whichever has higher valence in the molecule, that acts as the central atom. And for that we can apply the above examples and solve the